Hey everyone, welcome back to Scalar. Today in this video, we will talk about LangChain core concept and LangChain library structure. But before we get started, make sure you subscribe to the channel so you don't miss the rest of the Agentic AI playlist. And if you are serious about building a strong career in AI, check out Scalar's Advanced AI and Machine Learning program, co-certified with IIT Roorkee CEC. It's designed to help you master the skill needed for the real-world AI role and get you ready for that. For more information, check the link in the description box. Also, tell us in the comment what other AI topics you would like us to cover. So let's get started. So in this particular video, we are going to have a detailed discussion around what is LangChain library and what are the various components of the LangChain. Also, in this video, we will look at the various sub-libraries of the LangChain framework. So if you have ever worked with LangChain, you would have seen that there are multiple libraries that are available for LangChain. For example, LangChain Core, LangChain Community, LangChain Experimental, LangChain itself. So there are multiple libraries available. Now the confusion among the people is that which library has to be used in which kind of scenario. So we will have a detailed discussion around that also. So let's get started. So first of all, let's talk about the entire requirement of LangChain framework. As I have mentioned in the previous video also, that LangChain as a library is available for you to create AI applications, to create applications that are AI driven, to create applications that are powered by AI. And in the last video, we also had a detailed discussion around what exactly is AI for us. So LangChain framework was designed, and this is an open source library in Python, which was designed to help developers create AI powered applications. So this was basically the core objective of defining and coming up with this particular library. Now this library has multiple core components also. We will talk about it, but let's take one application or one example of AI application, AI powered application, and then we can talk about multiple components. So let's say you want to come up with a AI application that can basically let you chat with your PDF file, let you chat with your PDF file. Now, what all components you would need to come up with this application? If you talk about today, and if you go to the LangChain or maybe any website, any LLM powered website, be it ChatGPT or be it Gemini, you can directly upload the entire PDF, given that this PDF has to be in a allowed context limit, and then you can directly chat with your PDF. So this functionality is available in various LLMs and in their web interface. But what if you want to come up with your own application? Let's say you want to come up with your own mobile application, which can let you do the exact same thing. So the problem is that if you want to come up with such application, there is a problem number one. Problem number one is that if your PDF is huge, let's say it has 1000 pages, then you cannot simply provide this entire PDF to your LLM. That's problem number one. The second problem is how would you orchestrate or how would you bind your PDF with your LLM? And remember, we are creating application. So when I say application, we are basically building up a mobile application where I can upload my PDF file, and then this application will allow me to chat with my PDF. So we need to come up with some kind of infrastructure, or I would say system design, that can help me get this task done. Let's try to create a flow chart or a mental mind map to understand how this system architecture of this application would look like. So number one thing what I will do is I have to reduce this size of the PDF, and the simplest possible way. And before that, when a user, so let's say this is my mobile interface. So this is my mobile interface, and here you have the option to upload the file. So upload. Now, when your user uploads the file, you need some kind of system which can load your file, which can allow you to get your file in this entire system which we are trying to come up with, or the application. So let me just create this blue boundary, and let's assume that this blue boundary is basically the application that we are trying to build. So this is requirement number one, and I will mention all the requirements in, let's say, this orange color. So my requirement number one is I need some kind of loader. A loader basically means a particular program which can allow someone to upload their file, and then this program will take that file and will load the file into my entire application. So this is requirement number one. We need some kind of loader. Now, definitely we cannot provide this entire PDF to my LLM. So we need to split this entire PDF into various sub PDFs or sub, I would say, chunks. So this is a technical term, but let's use this term because we'll be using this terms variety so many times now. So second step is that I need to break down this entire PDF into multiple sub PDFs known as chunks. So these are my chunks. And let's assume as of now that each page is a chunk. So each page is a chunk. Now there will be multiple such pages. Now what is the system requirement over here? I need some program which can allow me to break this entire PDF into multiple chunks. So this is my requirement number two. I need some kind of splitter. Now what I need? Now definitely my LLM cannot understand these textual data, and any machine learning algorithm cannot understand these textual data. The machine learning algorithm or LLM can understand numbers. So we need some kind of mechanism to convert each of these chunks into a represented number, and that is known as an embedding. We will talk about it in the next video, but as of now, embedding is basically a vector representation of this textual data into a number. So now the requirement is I need some numerical representation of this page, numerical representation of this page, and numerical representation of this page. Basically, numerical representation of each page. Let me put some numbers over here just for these are some random numbers. Now here we have requirement number three. I need some kind of program which can let me convert my textual data into these numerical representations which are known as embeddings. So let me put this also as a requirement. We need embeddings. Now once this is done, now the user on this particular mobile application will also send the query or the question. So let's say this is the user, and this user has sent a question, also a query. Now, once this query is sent, I need the LLM. So let's say this is the LLM, and I need this LLM to understand my requirement, my questions. So this is another system requirement. Then I need this LLM. But how I will be searching the relevant document? Because what I have done is I have splitted my entire document into multiple chunks, and then I have converted each chunk into some kind of numerical representation, which is known as embedding. Now, I also need to make sure that these embeddings are preserved somewhere, because I cannot do it again and again. Once I have done this part, once I have converted the various pages, which are chunks, into embeddings, I need to also preserve them in some kind of location. So that is where the concept of vector database comes into picture. So this is my vector database. Vector database. Now again, here we have a system requirement. I need some program that can act as a vector database. So this is another system requirement, vector database. Now, once the user will send the question to this application will send the question to the LLM. And before I can trigger the LLM, I also need to find out the relevant page from my PDF, which might have the answer to the question or to the query of the user. So this question will also go, or first it will go. Let me just delete this LLM as of now. So first, this question will go to a program which is known as the retriever. Retriever. Now, what is the usage of or functionality of this retriever? This retriever will go to this vector database and will fetch all the relevant documents or the pages which might have the question related to my query, or which might have the answer related to my query. So let's say these are my retrieved pages. So I will get, let's say these are the two pages. Now, final step is I will take this question. So I will take the same question, or let me do it like this. I will take the same question and I will add these retrieved documents. And then finally, I will provide this to my LLM, which can now answer my question. So this is the entire process. Now let me also highlight the system requirement. So we need a loader over here, which can load the document which has been uploaded by the user into this entire application. We need a splitter which can split this entire document into various pages or chunks. We need some kind of program that can convert these chunks into embeddings. Then we need a vector database which can preserve all these embeddings in a permanent location so that we can reuse it multiple times. We need a retriever also, a program that can help me to retriever. Then we need this tool which can combine. So let's call it as a combiner. Then we need LLM, and then we are done. Now you can see that in order to get this task done, basically in order to let someone chat with their PDF, we need a variety of tools. We need a variety of programs which are working together to let us chat with our PDF. Now, what you have seen right now is basically known as a RAG, retrieval augmented generation. So RAG. But we will have a detailed discussion on what RAG is. As of now, I have just given you a small glimpse of what exactly this application looks like. And the reason we are talking about it is because we need to understand the importance of LangChain. So this entire application can only be built when we have these smaller programs available to us, right? Now, one option is you write the entire code by yourself. So you write the code to allow you load the PDF file into this application. You write the code which can split the entire PDF into multiple chunks. You write the code which can convert your PDF, which is text, into representative number, which are vectors. Now that is going to be a hell lot of task, right? And that is where the the creators of LangChain understood this problem, and they came up with this library, which is LangChain. So that was the motivation behind coming up with this library. So LangChain as a library is a powerhouse. It's basically a powerhouse which provides you with all these additional programs together with your LLM. So you need multiple other programs together with your LLM to build the entire end-to-end AI powered applications. So if you are someone who is willing to create AI powered application using some kind of coding mechanism, then LangChain is the answer. And that is where the origination or the creation of LangChain started. So we will have a detailed discussion on this RAG pipeline and how this RAG is functioning. But as of now, my motivation was not to make you understand RAG, because we will have a detailed discussion on RAG. As of now, my objective was to help you understand why we need LangChain. LangChain is a very powerful framework which provides you with all the necessary components which you need together with your LLM to create a AI powered application. That is what LangChain is. Now the question is, what are the components which we have in LangChain? So let's talk about the components of LangChain. So we have multiple components of LangChain. Number one is the models. Number two, we have prompts. Three, we have chains. Four, we have memory. Five, we have indexes. Six, we have agents. So these are all the components of LangChain, and we will talk about each one of them in very detail. Also, when we need to use what kind of component. Let's start with model component. Now, and I have also created this image to help you understand each component. So right now we are over here, the core layer, which is the foundation layer, where we have various chat models over here. So here we have various chat models. We have embedding models also. We have LLM integration also. So let's talk about this very first component, which is model. Now models are nothing but those LLMs which allow you to get the power of NLU, which is natural language understanding, natural language understanding, plus the generation. So they can understand your language, they can also generate. And the reason model or these models, this component was created is because LangChain was thinking of making sure that the entire access of variety of LLMs is standardized. Now let me support my answer with one example. So as of now, you can see that over here I have created some code. As of now, please ignore all this. We will have a detailed discussion around what this is. So please ignore it as of now. I want all of you to focus on this. So when OpenAI launched, OpenAI also launched their package, which was OpenAI. So from OpenAI, import OpenAI. And now you can chat with OpenAI in your code using their client. So client openai.chat.complete. So basically you can see that this is a code which we have written on top of the package which is provided by OpenAI. This is one kind of a chatting model. Here you can see we have a different code for Anthropic. Anthropic basically the creator of Claude. So here you can see we have Anthropic and we have instantiated this. Then this is client Anthropic model system. So here you can see that we have a different structure. Here we have a different structure and here we have a different structure. The way you see the response is over here we are using choice.message.content. Here we are using directly the content.text. So you can see that if you are a machine learning engineer or maybe AI engineer and you are willing to create your AI application, let's say using OpenAI, then the way to chat with OpenAI using their native library is very different from what it is with the Anthropic. That means whenever you are willing to change your model, let's say someday you don't want to use OpenAI, you want to use Anthropic, or maybe let's say you don't want to use Anthropic, you want to use Gemini. So if you use their native libraries provided by Chat, OpenAI, and Anthropic and Gemini, you would also need to change your code, and that was the problem. That is where these LangChain people understood and they created the first component of their library, which was chat model. So they said, no matter which particular LLM you want to chat with, or no matter which particular LLM you want to integrate in your application, you don't need to change your code. All you need to change is basically the chat model. And that made the AI engineers and all the people who are creating AI applications to standardize their code. Now look at over here, and this will make you clear, like everything will be clear now. From LangChain underscore OpenAI, we have chat on OpenAI. From LangChain underscore Anthropic, we have chat Anthropic. The way we have called chat OpenAI, the way we have called chat Anthropic is exactly the same. Just see, we have defined the model which I want to use. We have defined the model from Claude which I want to use. The way I invoke or execute the OpenAI and Anthropic is exactly the same. The way I read their content or the output is also exactly the same. So now you can see that you need to change minimum code, but all so without making much of the change in your code, you are able to switch from one particular chat model to another chat model. And that was the major advantage of chat models, which was the very first component of LangChain. So that is what we were talking about. So whenever you create an application, which is AI powered application, so this is your AI powered application. Now you do not need to worry about using various libraries. You use this chat model and you will be able to connect yourself with OpenAI or Gemini or let's say Claude or any other. It has the access of multiple chat models. So if you go to their documentation, let me try to quickly show you that. So let's go to their LangChain documentation, LangChain chat models. And let's go to the documents. Here you can see that you have multiple chat models: Chat Anthropic, Chat OpenAI, Azure, Vertex AI, Chat Google Generative AI, Chat Grok, Chat Bedrock, Hugging Face, Olama, Watson, XAI, NVIDIA, Coherce, Mistral, Together, Firework. You can see that we have Perplexity also. So now you do not need to worry about um, changing the entire code. You just need to change your LLM provider and you are done. That was the major advantage of the models. Now, another big advantage was that this model comes up with another component which is known as the embedding model. So you have some LLM models which are providing you with NLU power, which is natural language understanding plus generation. We have embedding model also. Embedding models are those model which basically converts your text data into vector representation. So again, here you have multiple embedding models. We have OpenAI embedding, we have Claude, which is Anthropic, and so on. And let me show you that also. If I go back to my code, you can see we have embedding model from LangChain underscore OpenAI import OpenAI embedding. And guys, please don't worry. We will have a great detailed discussion around how to use them, how to write everything. As of now, I'm just creating the broad understanding about the entire LangChain framework. So please don't worry. We have just instantiated this OpenAI embedding. I'm using this model, which is a small model. And we wanted to convert this text into the vector. And this is how the vector looks like. You can also convert multiple text, which are known as the documents, using embed documents. So if you want to just convert one text embed query, here we have embed document. Here the output is a vector. Here is it is basically a list of vectors. So this is the only change. But this is another chat, not the chat, another model that comes under the model component of LangChain. So in nutshell, when we talk about the first component, which is model, we have some chat models which let you use your favorite LLM and provides you with NLU functionality plus the generation functionality. We have some embedding models also, which lets you convert your text to vector. Now, the good part and the major part is you do not need to change your code while you change your LLM provider. So if you want to use OpenAI, just use Chat OpenAI. If you want to use the embedding model from OpenAI, use OpenAI embedding. That's it. That's the only change you need to do. And that is what the very first component of your LangChain was, the model component. And I hope you guys understand why we need it. We need it because I don't want to change my code by changing the entire library. I just want to change my LLM provider, and this framework LangChain will make sure that by making minimum change in my code, I am able to change my LLM provider. That was the very first part. Prompt, second part. Now, what is a prompt? Prompt is basically a way to guide or to instruct or to talk to your LLM, right? So you guys would have seen a variety of videos where people are teaching about how to write a good prompt and basically some prompting technique. You would have seen some advertisements about becoming a prompt engineer also. So you would have understood that prompt is a very important component of interacting with any LLM. And that is what LangChain has also understood. Prompt in LangChain provides you a dynamic way to write prompt. Dynamic way to write prompt. Now, I hope and I believe you are not getting this. So let's take one example. Let's say you have one AI application, and this AI application will take your city name, and this AI application will write you a let's say 10 points about why to visit this city, why to visit this city. Now you can not use this application without you have written a good prompt that is connected with the LLM, right? So in the backend or inside of this particular AI application, you would have a prompt plus you will have a LLM. Now how this prompt will look like? This prompt need to be dynamic, right? Which basically mean this prompt need to be something like this. Uh, you are a travel guide. Provide me 10 points why I should visit this city. And let's say after this, I have created a placeholder. Now you can create such prompts with a placeholder that is getting invoked on runtime. So when someone will be using this application on the runtime, the city name will come over here. This city, let's say I have provided the city name as Kanpur. So this city on the runtime will get inserted over here, Kanpur, and that is what is going to be the input to this LLM. This LLM will process it and will provide you the output. So this is how this application will work. And now you would have understood the importance of this particular dynamic prompt. Now, there might be a question in your mind why I cannot do this using a string formatting, which is natively available in Python, right? So you can format your string like this also, right? So if I want to do, I can show you that. And this is a very valid question which came to me also when I was creating this entire video. So why I need this prompt, why I need this prompt template and everything, why I cannot simply do something like this. So let's say like this. You are a travel agent and provide 10 points regarding why should I visit this city. And then I create a placeholder over here, and then I simply do dot format and I provide the name of the city, let's say Kanpur. And when you run this, you can see that now we have this string ready to be processed. So why I cannot use this and why I need a sophisticated method in LangChain to get this task done. Now remember, we are creating AI applications, right? So when you create AI application using a framework, I want all the components. So I need to go back over here. If you want this entire AI application to work properly, you need to make sure that each of the component of this framework is very well connected and very well working with the other component. And LangChain wants to make sure that whatsoever you do in their framework so that you do not need the glue code. Glue code is basically the code written out of a framework to connect one component to another component. And LangChain does not want you to do so. So that whatsoever you do within their framework, and you are able to connect one component with another component without using any kind of glue code, because if you use a glue code, your chances of making error will increase. And hence they created this dedicated component in LangChain framework, which lets you to write dynamic prompts. Now together with this, they also created, so I hope this part is clear why they created dynamic prompts. Now, together with this prompt, they also created some messages. So, messages are the data structures in LangChain. Now, what is the meaning of this? So, these data structures are nothing but like a tag to your prompt. So, we have AI message, we have um, user message, we have system message, and we have tool message. Now, why we need this? These messages are very much useful when you are writing a detailed prompt to let LLM understand what is the task and what is the instructions. Task and instruction. Let me explain you this. So as of now, if you try to look at this particular prompt, this prompt has two components. One is the user message, which is Kanpur, and this is entirely the system message, which is the set of instructions. And what you will get in the output will be your AI message. So while you write a prompt, it is also very useful to tag what is coming from which particular part of the entire application. If you are writing, let's say, some set of instruction, and if you tag it with system prompt, your AI will be easily able to discriminate or distinguish between what has to be done and on what it has to be performed. So let me show you one example to support my answer. So here you can see that we have from LangChain underscore core messages, human message, AI message, system message. And all this is doing is creating a, so let me just run it and I hope I would be able to run it. Let me just show you human message. So here you can see that this human message is a wrapper with this particular tag human message, which has a content, which has some additional keyword arguments, response metadata, and the name is user. So this is how LangChain will create a wrapper of a user message. Similarly, it would have created a wrapper of AI message and the wrapper of system message. Now, why I need it? I need it so that your, okay, I need to print all of them otherwise. So let me print human also. Let me print AI also. And let me print system also. So here you can see that we have, this is my human message, this is AI message, and this is system message. User, assistant, and system. Now, why we need this? These are indicators to my LLM that which component of my prompt is coming from which kind of person or which kind of user, whether it is the instruction, which is system, whether it is message from a human, which basically means on what this task has to be done. And then finally, the response from AI is always tagged as AI message. This is also useful when you create memory. Now, I will tell you that in the next part, basically when I reach to the memory component. But these tags are very much useful when you create the memory and when you preserve all these responses one by one. So messages are useful, number one. to tag what prompt is coming from which person. And when I say person, I means application. Second is it also helps in memory arrangement. When I say memory arrangement, I basically means if you have tagged your message that this is AI message, this is system message, this is user message, it is easy to organize this entire chat history in your memory. So easy to organize the entire chat history. I will talk again about them once I reach to memory. So this was your prompt section. Now the third one is chain. Now what is the meaning of chain? Chain is such an important component of LangChain that the name LangChain as a framework was given to it. Chain. What is the meaning of chain? Chain is nothing but a series of process. So for example, if I want to create one application, AI application, where I give a city name, this city name goes to the prompt where it creates a dynamic prompt. Once my prompt is ready, it goes to my LLM. The response I get from LLM goes to another LLM, which creates, so this LLM is creating long text about that city. And this LLM is summarizing the text. And now you are getting the output. Now, if you see this entire framework or this entire system, you are able to understand that this is a process. This goes to this goes to this goes to this, and then finally you have the output. Now, if you try to do this, which is connecting one output and the input, output, input, output, input, output, input, it will be very difficult to do it in native Python. You have to write a code in a way that it is easy for us to do it entirely. So LangChain understood this process. LangChain understood that whenever someone will create AI application, there will be a lot of applications where the output of the previous step will act as an input to the next step. And that is where they created the concept of chains. So chains will allow you to standardize or to generate this entire process without you defining that this output of the previous step will act as the input. You just need to put all these components one after the other in a chain, and LangChain will be able to process it. It will automatically take the output of this step and will provide this step with the input. Then it will take the output of this, will provide this to the input, will take the output of this, provide this to the input, and finally the output is given to you. So this will automatically happen because of the chains in LangChain. Let me quickly show you one chain, very simple chain in LangChain. Again, we are going to have a detailed discussion around how to create it. But as of now, I'm just helping you with a very surface level view about how chains looks like. So here you can see that we have created a prompt. This prompt is answer this question, and this is my question. So this is a dynamic prompt that I have created. This is my LLM. I'm using chat OpenAI, and this is my parser. Now, what is the usage of parser? It is just taking the output, and we will have a detailed discussion around what is parser. But as of now, the LLM returns you the output, and this parser will take that output and will return you a plain string. So this is a string output parser. Now I have created a chain over here. So the prompt, so when I provide this prompt with my input, this prompt will take the input and will generate the dynamic prompt. This dynamic prompt will go So the output of this prompt will go as the input of this LLM, and this is the LCL. It is known as LCL in LangChain. So this is a pipe operator which enables the sequential chain. So this is a sequential chain. The output of this prompt goes to the input of LLM, and the output of LLM goes to the parser. And when you run it, so all you need to do is chain dot invoke. So I'm providing this chain, which is over here, with my question using the method invoke, and this is my question. And now you can see that we have the output, right? So using this chain concept and using the concept or the component of chain in LangChain, you don't need to worry about that this output has to be the input of another component. You just place all these components in a series or in any way you want to. So in LangChain, you not only have the sequential chain, you also have conditional chain, you also have parallel chain. So you have multiple kinds of chain which you can come up with, and all these chains will allow you to come up with sophisticated AI applications. The best part, you don't need to define that this is the output and it will be acting as an input to this component. You don't need to worry. LangChain has the process defined for you. Now the next component is memory, and I was talking about this, so let's understand what is memory. Now memory is very important for these applications because, as I told you, that this LLM is not something that is locally working in my system. This LLM, let it be Gemini, let it be OpenAI, let it be Claude, all these LLMs are running on their respective servers because the size of these LLMs are in GBs, 100 GB, 120 GB. These are very heavy models, and you cannot load them in your RAM. And we don't have 100 GB of RAM in our laptop. We cannot run these LLMs in our laptop, right? So they are running on a server. And now you are interacting with these LLMs using API with your AI application, which is running in your code, which is Python. And this is the API call. Now, the problem with these API calls are stateless. This basically means each message that goes to this LLM is independent of the previous message. So if I ask LLM, uh, who is the PM of India? Now, when you send this query Q1 as a input to the LLM, you will get the output. Mr. Narendra Modi. But now, if you immediately send the second question, which is how old is he? Now, your LLM, which is getting connected with you through a API, will not be able to answer this question. LLM will simply return you the response that you LLM is not aware about the context. Please help me the context of this question. Because LLM is not aware about to whom you are referring using this word he, and that is the problem. Because when you are creating such applications where you are letting your user chat with the LLM, then you need to also provide some kind of memory in place so that the LLM is able to retain some of the context of the chat history, and then LLM will be able to answer such questions. So that is where the concept of memory came into picture. So memory allows you or allows your AI application to retain the chat history that has happened between you or the AI application and the LLM. Now there are multiple memory that are available. We have simple memory also. We have summary memory also. So we have multiple memories. So one kind of memory is it preserves, let's say, n previous chats. So it will simply preserves past previous chats. So let's say past 5 chats, past 10 chats. Second kind of memory is the summary. So what it will do, it will take the entire chat history, will summarize it, and then it will preserve it. So we have multiple kinds of memory. We will talk about it. But I told you one thing, that I will again come back to these messages when I'll be talking about this memory component. Now, when you are preserving your chat history in this memory, it becomes very crucial to tag which output is from which particular user or which component of this AI application. So let's say if I ask, who is the PM of India? Now, from where this particular question coming from? So this is my user. So I will tag this as user message. Then before that, I also have the system message. What is the system message? You are an AI assistant. So this is going to act as a system message. Now the response from the AI would be Mr. Narendra Modi. Now this I will preserve in my memory as a AI message. Then again, I can send another question. So my question is, how old is he? Now this will be again tagged as a user message. So I hope now you are able to understand that when you preserve your chat history in your memory, these message tag becomes really useful, because now when you send this entire history to your LLM, your LLM will be easily able to understand that this was the system message, this was the user input, this is what the previous output that the LLM generated. Now this is the next question from the user. And now LLM will be able to efficiently and effectively answer your question without making a mistake. That is what the message part is. I hope the memory part is clear to everyone. Let's now come to the, where is, let's come to the indexes. Now indexes are everything that you need in RAG. So indexes comprises of 4 components, and I have drawn it also. You can see that these are my indexes. We have vector store, document loader, text splitter, and retriever. So we have number 1, vector store, document loader, text splitter, and retriever. And I don't need to explain you again about all these things. I'll just explain you this in very short. So document loader are those functionalities of LangChain which will help you to load the document from various sources. Again, remember, you need all this to create RAG based application. Basically, where you are getting your external data and collaborating this external data with your LLM to let you get or to let you chat with your data using LLM. So that is what RAG based applications are, and we will have a detailed discussion. Again, I'm not taking you RAG, I am not teaching you about RAG, but all these components are required for RAG. First component is document loader. So these are those programs and functions that are available in LangChain which will let you to get the documents from various sources. For example, you want to load the document from a PDF file, from a SQL database, from a let's say Excel file, or from let's say some other application. So all these document loaders are available. Then text splitter. So there are various methods which are available in LangChain which will allow you to split your entire document into chunks. So there are various techniques. It is not simply based on let's say pages, or it is not based on, let's say, spaces. It is not based on, let's say, comma. So there are multiple techniques that are based on multiple methodologies and multiple logics. We will have a detailed discussion on that part also when we go into this component. But text splitter will provide you all these functionalities within the framework of LangChain. Then we have multiple vector stores also, where you can preserve your vectors, which is the text converted to number. So we have FIS vector store, ChromaDB. All these vector stores are available, where you can preserve your entire vector, which is text converted to number, in some location, which is acting as a database. Retriever, those programs which perform semantic search. So basically this part. So this retriever will take your question, will go to the vector database, will perform the similarity search to find out the similar document as per your query, and then will return you the similar document. So these are your indexes. Again, I will go about in the detail of each component when we will progress to the rack component. As of now, I am just explaining you the components of LangChain. The final component is agent, and this is something that most of you must be excited about. Now, agent is basically that component of LangChain which allows you to create agents. Now, what is an agent? Agent is basically a particular LLM working with a tool. And I have taken one example in the previous video also. Let me quickly recap that. So let's say you want to create a particular agent which is capable of finding out the best flights for you. So you provide your detail in a natural language. So find me a flight from Kanpur to Bangalore on 12th December 2025. Now, when you provide your question in plain English, your LLM will first understand your task and will also decide that there is a requirement of using a tool. So let's say this particular tool is my flight API, Google Flight API. Now, this LLM and this tool will work together and will get you the response. Now, this is what one agent is. This is not agentic AI, this is one agent. So, agent is very specific to one task, and this agent is specific to finding out the best flight for you. An agent is a combination of a tool plus LLM, and that is a kind of system which you can come up with in your LangChain also. So LangChain provides you with the functionalities of creating such agents, the functionalities of various tools also, and the functionalities of creating end-to-end agentic AI frameworks also. So all this is available over here. And in the last video of this series, we will create such agents also. So these are the components. Now, you can see that I have created a summary over here where I have provided all the LangChain components and from bottom to the top, and you can read it. You may pause this video and you can go through it. I have tried making it as detailed as possible. But there is a great amount of confusion among the students, and even I was confused regarding why we have so many packages from the LangChain framework. So if I just note them down, we have LangChain one package, we have LangChain underscore core, another package, we have LangChain underscore community, another package, LangChain experimental, another package, LangChain underscore OpenAI, LangChain underscore Anthropic, another package, LangChain underscore text underscore splitter, another package. So why so many packages? And after having a great amount of research, I was able to come up with this flowchart, and I'll just zoom this little bit more up. So what happened when LangChain, the creators of LangChain, when they started working on defining this library, they they thought of defining LangChain as a monolithic library, which basically means one library for everything, and they never thought of creating multiple libraries. But as things progressed, they started thinking and they started facing a lot of difficulties, because what was happening, some things were getting outdated, some things were getting new additions. The community was also contributing, the LangChain and the people with working with LangChain was also contributing. So so much problems were happening, and that is when they decided they will go into an hierarchical setup of this entire library. So the major library which we all will be using a lot is LangChain underscore core. This is the very important library which we will be using a lot. So if I have to create a prompt, I'll be using LangChain underscore core for defining messages, for output parsers, for tools, for runnables to define our chains, for language models, for callbacks to basically understand where my application is going wrong, for documents, and for exception handling. So LangChain underscore core is the core library which will provide you with all the core components to create your AI application. Now, if you want to chat the language models are further provided in various libraries. So we have a dedicated library for LangChain OpenAI. So this provides you with all the language capabilities working with OpenAI. So here you have embedding model also. Here you have chat OpenAI model also. Then we have LangChain Anthropic also, which is dedicated to Claude. So if you want to chat with Anthropic, then you can use their library. Again, this is a LangChain library, but leveraging the Anthropic capabilities. So it is like LangChain is the base, Anthropic is kept on top of it, and all these are getting a reference, or they are inherent to this base language model. That is the best part. So now you do not need to use their library. They have created their own library which is inherent to the base model of LangChain underscore core. So we have Google also, Vertex also, and here we have Hugging Face also. LangChain underscore Hugging Face. Now we have LangChain underscore community also. So all the functionalities that were generated by the community, people who are not the part of the core team of LangChain but are working independently to contribute. So all these functionalities were deployed or made available in the LangChain underscore community package. So we have vector stores, something which we will use, vector stores are provided by LangChain underscore community. We have document loaders, we have embedding models, we have tools, and we have memory. All these are contributed by the community, not the part of the core framework of LangChain, but it is maintained and written on top of LangChain. So LangChain is again the base which is providing the inherent property to these all other packages. Then we have LangChain underscore text splitter, which is another library providing you all the functionalities of splitting your data or document into multiple chunks. We have LangChain underscore classic. So this library comes with all those classical functions which were depreciated in LangChain underscore core. So these are like older functions. Now it is the part of classic. We will not be using them, but I might show you this functionality of retrievers over here. And we will also be using the hub, LangChain hub also. So again, some part or maybe some discussion will happen in classic part also. Then we have LangChain underscore experimental also. So anything that is happening new, something which is coming to the market, something which LangChain community is trying out, something which LangChain has just launched, this will be available in LangChain underscore experimental. This is research only. Then we have Langsmith. Now, Langsmith is basically like a library which provides you various functionalities to keep a track of your AI application. Let's say you want to trace, you want to check the health of your AI application. All these functionalities are available in Langsmith. We will not be discussing this a lot, but I will touch upon it. We have LangGraph. So this will be our next playlist. Again, LangGraph is also very powerful. I will tell you the detailed discrimination and difference between what is LangChain and LangGraph in maybe in the last video. But LangGraph is another library provided by LangChain underscore core, which allows you to create agentic AI workflows and sophisticated agentic AI. Then we have LangChain over here. Now, this is something which we will not be using a lot and nobody uses it a lot now. LangChain is the first library, but now it has been bifurcated into so many libraries. So it is high level orchestrations. Here I'll be using the agent framework over here when we'll be creating the agents. So you can see that these are all the components, but I know you guys must be getting overwhelmed by looking at this. So I created another image which oversimplifies this entire process, and let me zoom it also. So do you need autonomous agent with tool? We use LangChain so this is the LangChain library that I will use to create agents. Are you processing documents for RAG? Then we use LangChain text splitter. Connecting to external services, then we use LangChain underscore community. So for example, I need embedding models or I need vector stores. So that is where LangChain community is available. Do you need a specific OpenAI Anthropic? Then we can use LangChain OpenAI, LangChain Anthropic, LangChain Google GenAI. Building something abstraction. So do you want to build your own functions on top of the LangChain core? Then we need LangChain underscore core. Do you want to monitor your production evaluation and deployment? Langsmith. Do you want to use the legacy code? Then we have LangChain classic and LangChain experimental. So this is how you can decide which particular library from the LangChain we need to use. And believe me, guys, I have spent a lot of time to come up with this diagram. And after doing a lot of research, reading the various documents from the LangChain, I was able to come up with this. And this image has been created by Gemini, but the entire flow chart was created by me in a paper, and then I provided it to create this particular flow chart for me. So I hope this is helpful. I hope you guys are understood and have made a clear understanding about what exactly is LangChain and what are the various components of LangChain. So model, prompt, chain, memory, indexes, agents, and then finally, what are the various libraries of the LangChain community, not community, entire LangChain, and when to use which kind of LangChain library. So I hope you guys enjoyed this video. Please drop your comments, please drop your feedbacks, how this video was. If you have any suggestions for us, like let's say if you want me to add something or maybe reduce the video size, you can let me know. But I always try to make sure that I am coming with right set of enough information for all of you. So if you like this video, please subscribe to our Scalers YouTube channel.